This is Mrs. Butcher, and this video is about hyperbolas. This is section 9.5 in your Algebra 2 textbook. Okay, so the technical definition of a hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from any point on the hyperbola to two given points called the foci is constant. What that means is if I took a point on the hyperbola, measured the distance to this point and the distance to this focus over here, and then subtracted, and then if I did it again at another place and did this and subtracted, no matter where I measure that, the difference is always the same. But really, you don't need to memorize that. Just need to look at this diagram, and we need to know all these parts. So I'm going to scoot it up. Okay. Now, it looks confusing at first, but let's just break it down. We always start with a center, and that center will always be HK. All right, we always have vertices, so here and here. This is a horizontal hyperbola, so our vertices would be on the horizontal axis. And the distance is the same as with ellipses, the distance is A. We also have foci, but this time our foci are outside of the vertices, and the distance to each focus is C. But then we don't have covertices. What we have are asymptotes. And we're going to take B and count that as the rise of our slope. A is the run of our slope. And so then we have these asymptotes. There's one here and then the opposite one here. So if you can plot your vertices, your foci, and your asymptotes, you have everything you need to then just draw this red line here, this red curve on either side. And that's your hyperbola. Okay, so here we have another set of diagrams. This time we have one that's horizontal, it opens left and right, and we have one that's vertical, it opens up and down. So on our horizontal hyperbola, we have our centered HK, and that shows up here and here. And then we have our A, which is the distance to your vertex, and it's left and right. And then you've got B, which is going to be the rise of slope in your asymptote. Rise B, run A. So if you look at this, the equation for horizontal hyperbola, x minus h squared over a squared minus y minus k squared over b squared equals 1. The only difference between the horizontal ellipse equation and this one is this minus right here. Hyperbolas always have a minus, not a plus. All right, and then our vertical hyperbola, it's the same thing. A is your distance to your vertex. HK is your center. And then your asymptote on the vertical, you're going to rise A and you'll run B. So that's BA. It just depends on whether it's a vertical or a horizontal. So your equation y minus k squared over a squared minus x minus h squared over b squared equals 1. A key thing to remember when you're doing hyperbolas is in ellipses, we based the horizontal versus vertical on which one had the larger denominator. But in a hyperbola, we base it on whether it's positive or not. The horizontal hyperbola has the x part being positive and the y part being negative, and the vertical hyperbola has the y part first, or positive, and the x part is negative. So it doesn't matter which one is bigger. We could have a bigger denominator on the negative part and still have it be vertical because the y part was what was positive. So you have to be careful about that. All right, so let's do a few examples. We're going to graph x squared over 81 minus y squared over 64 equals 1. So the first thing we're going to do is locate the center. Center is HK. And since we don't have an H and we don't have a K, our center is at 0, 0. And we're going to put the point there. All right, now, in the x direction, this is A squared, so A is 9. In the x direction, I'm going to go 9 units to the right and to the left. So there's one vertex, and there's the other vertex. So our vertices are are 9, 0, and negative 9, 0. And to save space, we're going to put plus or minus 9, 0. All right, now we don't have co-vertices, but we do need foci. When you're doing hyperbolas, to find your foci, to find your c value, it's a squared plus b squared equals c squared. When you were doing ellipses, that was a minus. When you're doing hyperbolas, it's a plus. So I was trying to underline, not add a minus. It's plus when this is hyperbolas. I always just remember, okay, hyperbolas have a minus here and a plus here, and ellipses are just the opposite. So if a is 81, a squared is 81, and b squared is 64, when we add those together, we're going to get 145. So that means c is the square root of 145. And I've decided I'm going to let you guys give me decimals. That's approximately 12.04. So our foci, we're going to count 12.04 on either side of this center here. So that was 9, 10, 11, 12.04. It's off my grid. And of course I didn't leave room for it on the other side, so we'll just have to imagine it over there at 12.04. So we've got 12.040, and it's positive and negative. All right, now we don't have co-vertices, but we do have asymptotes. And the equation of your asymptote is always y minus k equals plus or minus rise over run of your slope, and then x minus h. But in this case, we don't have an h or a k, so we just have y equals plus or minus something times x. Our rise in the y direction will be the b value, and in this case, b is the square root of 64, which is 8. So we're going to rise 8. And then in the x direction, we're running square root of 81. We're running 9. So our asymptotes are y equals plus or minus 8/9 x. We're going to rise 8 and run 9. Now, some people like to draw a little rectangle. It's not required, but if it helps you, then you're welcome to do it. This little box here tells you the corners where your asymptotes go, just like this. The asymptotes are required to be drawn into the graph. Ooh, that was crooked. All right, so we've got our vertices, our foci, and our asymptotes. Those are the 3 required parts. And then all you have to do is put your pen or pencil on the vertex and approach your asymptotes with a curve, and you're done. Just don't forget to actually draw the curve. Okay, here's another graph. We're going to do 5 times y plus 3 all squared minus 9 times x minus 6 all squared equals 225. So the first thing you have to do is say, oh, okay, standard form, it's supposed to equal 1. So to make this equal 1, we have to divide everything by 225. And you have to do that to each piece of the equation. So now if I reduce 5 over 225, not 5, sorry, this is supposed to be a 25. Typo, 25. There's a 2 here. Let's do this. Okay, that's supposed to be a 25. And so 25 over 225 reduces to 1/9. So that's now y plus 3 squared over 9 minus, and then 9 over 225 reduces to 1 over 25, so x minus 6 squared over 25 equals, and then 225 over 225 is our 1. So now that it's in standard form, we can locate our center. The center is always at hk. So in this case, h is 6, k is -3. Be careful. A lot of people put 3 -6 because they see that this is first, but it's always h with the x, k with the y. So 6 -3, right there. And then our a value is 3, and it's in the y direction. So I'm going to go up and down 3 from my center. So 1, 2, 3, there's a vertex, and 1, 2, 3, there's a vertex. Those vertices are at 6, 0, and at 6, negative 6. Okay, we need to find c, so we're going to say a squared plus b squared equals c squared. C is the square root of 34, and that's approximately 5.8. So we're going to go up 5.8, put a focus, and down 5.8, and put a focus. And the ordered pairs of our foci are 6. And then if I took negative 3 and added 5.8, I'd have 2.8. And if I take negative 3 and subtract 5.8, I have negative 8.8. Oops, 6 comma negative 8.8. All right, our asymptotes, this time we're going to rise 3, because in the y direction, we're going to rise 3. And then we're going to, in the x direction, run 5. So we're going up 3 and over 5. For that asymptote, and then rise 3 back 5 for that asymptote. We're going to write them down. The equation is always going to be y minus k, so y plus 3. We're just using this right here. Equals plus or minus rise over run. So in this case, we rose 3 and we ran 5. And then parenthesis. Oh, can't scoot that over. And then x minus h. So x minus 6. Sorry, that's supposed to go up there. All right, the very last thing you need to do is actually connect your dots. We're just going to put our pen on the vertex and approach the asymptotes with a curve. So that's it. Okay, for this example, we want to write an equation for the hyperbola with foci at 3, 0 and negative 3, 0, and vertices at 2, 0 and negative 2, 0. So whenever you're given information like this, it's best to sketch a picture for yourself. Just sketch it. It doesn't have to be plotted perfectly or anything. But if our foci are at 3 and negative 3, and then our vertices are at 2, so that's a focus and that's a vertex, and negative 2, then that tells us by looking at the picture that this is going to be a horizontal. This tells us that the center is always halfway between the vertices. Our center is going to be 0, 0, so h is 0 and k is 0. A is always the distance from your center to your vertex, so your A is going to be 2 units. We don't know what B is, but C is always the distance from the center to a focus, so C is 3. The only other thing we need to write our equation is B. So we're going to use A squared plus B squared equals C squared, where A is 2, so we've got 4 plus B squared, and C is 3, so equals 9. That means that B squared equals 5, and B is the square root of 5. You don't really need B, though. To write the equation, all you need is B squared, because we have x minus h all squared over A squared, which is going to be 4, minus y minus k, which we don't have a k, so y squared, over B squared, which is 5, equals 1. So when you're writing the equation, you need to figure out what h is, what k is, what a squared is, and what b squared is. Once you've got those things, you can write your equation easily. And this is our last example. We're going to write an equation for the hyperbola. With vertices at -2, and -2, this should be at +4. And foci at -2 and 1 plus or minus the square root of 13. All right, so what we're going to do is sketch a little picture for ourselves. Vertices at -2, -2, and -2, 4. So that's here and here. So all of a sudden, I know it's vertical. I can locate my center because it's going to be halfway between. So that's at -2. And then halfway between 4 and -2, that's 6 units long. So this is 3 units, and that's at 1. So -2, 1. That tells us that h is -2, that k is 1. We also know the distance, that's a is 3. And then they also gave us foci. That said -2 and then 1 plus or minus the square root of 13. The square root of 13 is between 3 and 4 units long. So just a little bit above here, and a little bit below here. Put my V's in the way. But the fact is, our C is the square root of 13, because that's how much we went up and how much we went down from the center there. So now we can use A and C to get B. A squared plus B squared equals C squared. So 9 plus B squared equals, and when I square the square root of 13, I get 13. That means that B squared is 4, and B is 2. So now we have everything we need to write the equation. Verticals always start with y, so y minus k, y minus 1 squared over a squared minus x minus h squared over b squared equals 1. And that's the end of that. And it's also the end of the hyperbola video.